Have you ever wondered if you can fly in space? The idea of spaceflight has long captivated the human imagination, an adventure into the unknown that feels almost magical. But it's not just about the romance of the stars. It's a complex dance of physics and technology that stretches our understanding of the universe. Here on Earth, we're accustomed to the concept of flying. Birds do it, planes do it, even the leaves in the wind do it. But in the cosmic realm, the rules of the game change. There's no air to lift a wing, no gravity to pull you down. It's a world where the familiar laws that govern our everyday life are replaced by the strange and unpredictable rules of the cosmos. So, what does it mean to fly in space, and how do we, as terrestrial beings, grapple with this alien concept? So, the question remains, can we really fly in space? Let's dive deeper. To understand spaceflight, we first need to understand how flying works here on Earth. Let's break it down to the basics. Fundamentally, flight on Earth is a delicate dance of forces, a careful balance between gravity, air resistance, and lift. It's like a tug-of-war between the sky and the ground, with the object in flight caught in the middle. Gravity, the force that keeps us grounded, is the key player. It pulls everything towards the center of the Earth. It's what makes an apple fall from a tree, and it's also what makes a plane or a bird work hard to stay aloft. But gravity isn't the only force at play. Air resistance, also known as drag, is the force that opposes the motion of an object through the air. It's like trying to run through water. The thicker the medium, the harder it is to move. Birds and planes are designed to be streamlined, reducing the effect of air resistance and enabling them to move more effortlessly through the atmosphere. Finally, to counteract gravity and air resistance, we have lift. Lift is the force that opposes the weight of an object and holds it in the air. Birds achieve lift by flapping their wings, changing the air pressure above and below them. Airplanes, on the other hand, rely on their wings' special shape, called an airfoil. The shape of the airfoil causes air to move faster over the top of the wing than the bottom, creating a pressure difference that generates lift. So in essence, flying on Earth is all about managing these three forces: gravity pulling you down, air resistance slowing you down, and lift pushing you up. It's a complex yet beautifully orchestrated symphony of physics. But what happens when these conditions change? What happens in space? Let's explore that in the next scene. Space, unlike Earth, is a vacuum. It's devoid of air, and gravity is not the same. This is not a place where we can flap our arms or spin a propeller and expect to soar. To understand why, we must first grasp the concept of flight as we know it on Earth. Here, flight relies on two essential elements: air and gravity. When a bird, an airplane, or even a humble paper airplane takes to the skies, it's manipulating these two elements to its advantage. Air, composed of countless tiny molecules, becomes a sea of opportunity for an object seeking to lift from the ground. Wings, whether they're on a bird or a Boeing, are designed to create a difference in air pressure. The shape of a wing, flat on the bottom, curved on top, means that air flows faster over the top than the bottom. Faster air equals lower pressure, and voila! Lift is created, but in space, there's no air. No air means no air molecules to push against, no air pressure to manipulate. Without this, the basic principles of flight as we know it are rendered useless. Then there's gravity, the force that keeps us grounded, quite literally. On Earth, gravity pulls us towards its center. But in space, gravity isn't so straightforward. It's weaker the further you move from a celestial body, whether that's a planet, a moon, or a star. This inconsistency of gravitational pull means that the steady, predictable fall towards the ground that allows for gliding flight on Earth simply doesn't exist in space. And so we find ourselves in a void, a vacuum that laughs in the face of our earthly understanding of flight. There are no air molecules to surf on, no predictable pull towards the ground to glide against. So traditional flight methods won't work in space. But does that mean we can't fly? When we talk about flying in space, we're really talking about moving or maneuvering in space. To understand how this is possible, let's start with spaceships. Spacecrafts move by using the principles of thrust and momentum. Unlike on Earth, where air resistance slows things down, in space, an object in motion stays in motion. This is due to Newton's first law of motion. To get a spaceship moving, we need to apply a force to it. This is usually done through the expulsion of rocket fuel. Once the spaceship is moving, it will keep moving at the same speed and in the same direction until another force acts upon it. But how about changing direction or speed? That's where thrust comes in. By expelling more fuel in a specific direction, the spaceship can alter its course or speed. This is an application of Newton's third law of motion. For every action, there's an equal and opposite reaction. Now let's talk about astronauts. Without a spaceship, an astronaut in space is like a bird without wings. But humans, being the ingenious creatures we are, have found ways to maneuver in this vast void. Astronauts can use their own bodies to move around. They do this by twisting, turning, and even throwing objects. Each of these actions creates an equal and opposite reaction, propelling the astronaut in the opposite direction. Astronauts also use tools to help them move. A popular one is the handheld jet thruster, which expels gas to create a force that moves the astronaut. It's essentially a mini spaceship for personal use. So when we talk about flying in space, we are not talking about flapping wings or gliding on air currents. Instead, we're discussing the manipulation of forces and momentum to move and maneuver in the vast expanse of space. So while it's not flying in the traditional sense, we can indeed move and maneuver in space. With advancements in technology, the future of spaceflight looks promising. As we continue to push the boundaries of human knowledge and capability, we're constantly discovering new ways to explore the cosmos. One of the most exciting prospects for the future of spaceflight is the development of new types of propulsion systems. Currently, most spacecraft rely on chemical rockets, which are effective but have their limitations. They require a lot of fuel, which adds weight and cost to missions. However, scientists and engineers are exploring alternatives. For instance, ion propulsion, which uses electrically charged particles to create thrust, is already in use on some spacecraft. It's incredibly efficient, allowing spacecraft to travel farther and faster than ever before. But that's not all. Scientists are also researching other exotic propulsion methods, such as nuclear propulsion, which could potentially allow us to reach distant planets in a fraction of the time currently required. There's even talk of harnessing the power of light itself through solar sails, using the pressure of sunlight to propel spacecraft across the vast expanses of space. As well as propulsion, researchers are investigating new ways to maneuver in space. Traditional aerodynamic principles don't apply in the vacuum of space, so we need to think outside the box. Techniques such as reaction control systems, which use small thrusters to change a spacecraft's orientation, are being refined and improved. And there's ongoing research into more advanced concepts, like using magnetic fields to control a spacecraft's movement. All of this is to say, the future of spaceflight is a realm of limitless potential. The ongoing research and experiments in this field are not only about improving technology, but also about expanding our understanding of what's possible. As we continue to innovate and explore, we're reshaping the very concept of flight itself. Who knows? One day we might even see humans flying freely in space. As we look to the future, the possibilities are as infinite as the universe itself. So, can you fly in space? Well, it depends on how you define flying. We've taken a journey from the wonder of spaceflight to the nitty-gritty of Earth's physics. We've examined the void of space, where the absence of atmosphere and gravity make traditional flight impossible. However, we've also discovered that space isn't a complete no-fly zone. Instead, movement in space is a dance of momentum and propulsion, a delicate balance of forces rather than a battle against gravity. Our understanding of spaceflight has evolved from simple rockets to sophisticated spacecraft, capable of deep space exploration and intricate maneuvers. The future of spaceflight is bright, promising not only more efficient ways to move in space, but also opening up the potential for human exploration beyond our solar system. While we might not be able to fly in space like birds do on Earth, the possibilities for movement and exploration in the vastness of space are truly limitless.